Number 5. Number 5 is under the same category as 3 and 4, which say solve using the quadratic formula. But when we solve using the quadratic formula, don't we always leave our answer in radical form with the square root sign? Unless it's a perfect square and goes away, which is very seldom. Well, all of these answers are in decimal form. So what may be an easier way to find the answer for this problem instead of quadratic formula? Graph it. Okay, so now it does say 4k squared, but isn't that the exact same thing as 4x squared? Okay, so when I graph it, I'll type in 4x squared plus 5x minus 26. So everybody needs to be doing this with me. 4x squared plus 5x minus 26. A lot of times kids get the wrong graph, and I'll always look back and they have a negative instead of the minus here. Okay, make sure you know that there's a difference between this negative button and the minus button. Then we graph it, and we see it cross how many times? 2 times. This one's pretty obvious where it crosses. That's at positive 2. Now over here, it's approximately negative 3 point something, right? So keep that in mind. Positive 2 on the dot, negative 3 point something. Look at your answer choices. So it has to be which one? A. Now, if it's not that easy, like say your choices are like 2, negative 3.25, 2, negative 3.4, and so they're really close, what can we do to get the exact location of this one? Second trace, but then what are we trying to find here? The 0. So we hit number 2, then you move your cursor around to it till it gets there. Oops, too far. Okay, first it says go to the left side of it, which in this case would be above it, correct? Because if I want to be to the left of this 0, I need to be above it. And then I hit enter. Then I move the little blinking thing to the right side of it, which is actually below it, and hit enter. And then I'll hit enter once more once it says guess, and it will tell me exactly negative 3.25. So that wasn't necessary for this one because the answers were not that similar, but just in case it is, I wanted to review it. Okay, number 6. Find the x-intercepts. X-intercept is just another word for zeros. Okay, so what would I do? I would graph it. Okay, so instead of n, I'm going to put what? X. So 2x squared plus 2x, what was it at the end, minus 4? Okay, it has how many zeros or x-intercepts, and where are they located? Negative 2, positive 1, which matches up with which choice? D. Okay, so those two problems are fairly easy. Now let's turn to the next page. Number 7, solve each equation by taking square roots. K squared equals 81. Okay, so if it says solve and there's a letter, you could possibly get that letter by itself. How would we get the K by itself? Square root it. To get rid of that power of 2, you square root it and it cancels it out, leaving K by itself. But whatever you do to one side, you must do to the other. What's the square root of 81? 9. Okay, but anytime you square root, what do you put on your answer? And why is that? It can be either. What's 9 squared? What's negative 9 squared? How come they both equal 81 when one of them is positive, one of them is negative? 2 negatives make a positive. Also, keep in mind that when you look at your degree, this is degree 2. So there's going to be 2 solutions. So that would knock C and D out right away just by knowing that there's 2 solutions. And then obviously it's the positive 9 and the negative 9. Okay, so how many solutions are we going to have in number 8? 2. Degree 2. So that knocks out which choice? B. Okay, so this time we're trying to isolate M. How can we isolate the M? Square root it. And so now we have M equals the square root of negative 36. Well, what is the square root of positive 36? But since it's negative, you put an I. Okay, now look, this could be tricky if you're rushing through this test. You might circle B. But remember, we already marked out B because we know there's going to be two solutions because it's degree 2. You've got to remember, since you square rooted it, you put a plus and a minus. So a positive 6i and a negative 6i are both the right answer. So see how it can be helpful to eliminate things? That way you don't accidentally pick that. Like as soon as you see 6i, you might be like, oh, 6i, and forget about the plus or minus. But if you rule that out at the beginning by just knowing there's two solutions, you won't make that mistake. Okay, now let's look at number 9. Factor each completely. Okay, this is a special case. Does anybody remember the name for this special case? Okay, what operation is going on? No, that's a made-up operation. What operation is this? It's a D word. Difference. It's subtraction. So difference. And it's a difference of two perfect squares, right? Remember when we factor these, what's special about them is they match everything except for the sign. Okay, because if you're going to multiply and get a negative, don't your signs have to be opposite? Okay, so if you're going to get a k squared, don't you have to have a k times a k? And to get a 4, 2 times 2. So that's answer A. Yes? Okay, look. Once we see it like this, okay, look, we could FOIL it. K times k is k squared. K times negative 2 is negative 2k. The inner terms make a positive 2k, and the last terms make a negative 4. These two cancel each other out. That's why all you're left with is k squared minus 4. Okay? So, guys, you've got to remember, to cancel out the middle, you have to have opposite signs. If you don't have opposite signs, the middle won't cancel out. Okay, so keep that in mind when we look at 10. Is the middle there, or is it canceled out? So what do you know about your signs? They have to be opposite. Otherwise, the middle wouldn't be missing. Now, to get m squared, what do we have to have in each one? M times m. To get 16, what do we have to have? 4 times 4. Okay, but then we have a problem. Because look, 4 times negative 4 is negative 16. But we're wanting it to be positive. So, if you put an I on each one, I times I will be an I squared, and what does I squared equal? Negative 1, which will turn that into a positive 16. Y'all remember that? Okay, so we didn't finish, well, we did finish it. There's the answer, so that is A. Now, let me show you something else that could help you with this. Say you're having trouble with this, why don't you look at it from this standpoint? M squared plus 16, set it equal to 0. Now that it's set equal to 0, how could we start solving it? Subtract the 16, and so m squared equals, then to get m by itself, we would square root both sides, and so m would equal plus or minus 4i. Well, isn't that what we ended up with, a plus 4i and a minus 4i? It's just they wanted it in factored form, so you have to write it as factors. Okay, number 11. State the multiplicity at the root of negative 4 for this polynomial. Okay, root is just another word for 0 or x-intercept. So if they tell you there's a 0 at negative 4, how is that written in factored form? X plus 4. So we need to bring our attention right here. And that x plus 4 is cubed. So that means it has a multiplicity of 3. So let me ask you this just for an extra question. What about if it has a 0 and the 0 is at 0? How do you write the factor for that? just an x. So if we go to just the x, what is its multiplicity? 2. What happens when there's a multiplicity of 2 on the graph? It's a bounce. What happens when there's a multiplicity of 3 on the graph? It flattens out. Okay, number 12. Write a polynomial in standard form that has the given zeros. Okay, how would you start this? Right, take the 3 zeros and write them as factors. So now, your only other option here is if you don't know how to do that, you could graph each answer choice. And you would be graphing them until you found the one that did what? Crossed at those 3 locations. But obviously nobody wants to sit here and graph all 4 of those. So if you can, remember, you take each of these zeros and write them as factors. So what would be the factor for negative 5? X plus 5. What about for negative 3? And what about for positive 2? Now that you see that, you'll probably know what to do. What do we do? Boil the first 2. So x times x is x squared. X times 3 is, then our inner terms are 5 and x, which make a, and our last terms are 5 times 3, which makes a 15. Right. Combine the like terms, so what do I get? Right. So now I'm finished boiling those 2 binomials, and I end up with this trinomial that I can distribute by the remaining binomial. So what do I distribute first? So x squared times x is, x squared times negative 2 is, okay, so now look, I've distributed the x squared times the entire binomial, so I'm done with it. Now I move on to the 8x and distribute it. 8x times x is 8x squared. 8x times negative 2 is negative 16x. So now I'm done with the 8x. Now what do I distribute? 15 times x is, 15 times negative 2 is negative 30. So now what do I do? And I can kind of already notice that there's only one constant value, so this is wrong. B's out. Okay, I combine like terms, so x cubed comes down. There's no other cube terms to combine it with. Negative 2x squared plus 8x squared is, so that rules out A and C, so it has to be D. The way they got this negative x is because negative 16 plus 15 is negative 1x, and then minus 30. Any questions? Remember, the only other alternative is to graph each one until you find the graph that crosses the x-axis at negative 5, negative 3, and positive 2. Okay, next page. Number 13. How many zeros does this polynomial have? 3. Negative 3 is the first zero, positive 2 is the second one, and what's the third one? Okay, so what if I had taken this x plus 3 and squared it? How many zeros would I have now? 4. That counts as 2, and then 3, 4. So if I cube this one, how many zeros do I have now? 6. 1, 2, 3, 4, 5, 6. That would be a bounce. That would flatten out. Well, you just add up the exponents. Okay, number 14. Divide those 2 polynomials. What method did we learn to divide polynomials? What? Synthetic division, okay? What do you have to do for synthetic division?
You change that plus 3 for negative 3 in the box.
Okay.
And then you go to negative 1, negative 7, negative 35,
Right, those numbers are coming from this polynomial. 1, negative 7, negative 35, negative 15. So right now we've just set it up. What's the first step of synthetic division? Bring down the 1. What do you do with anything that drops below the line? Okay, and that becomes, then you just basically do what it says. I mean, you can add each time. That's all you're doing. Negative 7 plus negative 3 is, then it dropped below the line, so we multiply it by the box and we get 30. Then that becomes multiply it by the box and you get, and that becomes, which is our remainder. So look up here, remainder 2, remainder -5, remainder +5. It has to be C. And look, we're right, 1, -10, -5. Okay, before I just go over 15, I'm going to give you a second to try it because I'm looking around and not many people have it done. So you go and try number 15. So what number do I put in my box? What numbers go here? Right. You've got to remember that it went straight from the x cubed term to the x to the first, so it skipped x squared. That means it was 0x squared, and we have to fill in the 0. Now that we've done that, what's step 1? Bring down the 1. Then that combines to a, it multiplies by that and becomes a, that becomes, it multiplies by that and becomes a, so the remainder is, so that rules out which one? D. Now you just look for 1, -3, -4, B. All right, number 16. Sketch the graph of each function. Approximate each real zero to the nearest tenth. This doesn't have choices on the test. There will be choices for every question. Okay, so what do I need to do? Graph it. So y equals x cubed minus 4x squared. What's next? Okay, and we're looking for the what? The zeros. Well, how many are there? And it's at negative something, right? Negative point something. Because it's not, this is -1, so it's smaller than that. How do you find the exact location? Second trace 0, because we're trying to find zeros. And then it says left bound. Well, left bound would be below it. So I go below it, and I hit enter. Then right bound, I would have to go above it to be on the right side of that 0, and then I hit enter. And then I hit enter once more, and the zero's at -0.31. Okay, any questions? You don't really have to sketch it because we sketched it on the graph. Okay? Number 17, same type of question. They want you to sketch it, which just means we'll look at the graph on the calculator and approximate each real zero to the nearest tenth. Okay, so first let's graph it. X cubed minus 3x squared plus 4. Okay, how many times does it hit the x-axis? Well, twice, but this
It's
counts
a
as a bounce, so that counts as 2 of the 3. So we have a -1 and +2. So the way you would see this written on the test is that you would have a 0 at -1, and you would have a 0 at +2, but they would write out beside it multiplicity of 2. And think about it, guys. We know it has 3 solutions because it's degree 3. Okay? All right, next page. Number 18, x cubed plus 64 equals 0. Any ideas how we're going to start this?
Yeah.
Minus 60.
Okay, let's look at that. If we subtract the 64 on both sides, you end up with x cubed equals -64. What would you do then?
You would, wait, you would cube it.
Well, it's cubed. How do you get rid of a cube?
Divide by 2.
No, that's if it's being multiplied by 3. Have we ever
No.
gotten rid of a cubed? We've
No,
only
just
gotten rid of
graph it.
squared. So, right, this is not the way to go. The way to go is to graph it. Okay, so let's go ahead and graph it. Guys, when in doubt, graph it. Okay? If you're not sure how to start a problem, you need to graph it, and maybe then it'll get your wheels turning. Okay, so x cubed plus 64. Y equals x cubed plus 64. Okay? Now, it's cubed, so we know it has how many solutions? But we only see one solution, and where is that one solution located? -4. So if we know that it has to have 3 solutions, and we know that one of the 3 is -4, what does that tell you about the other 2? The other 2 are imaginary. Now, knowing that the one real one is -4 doesn't really help you eliminate any answers because they all say -4. So what is the process to find the 2 imaginary solutions? Right, you use your one real root of -4 in synthetic division. So what do I write out for this polynomial?
0, 0, 64.
Correct. Then what do I do?
Bring down the 1.
Bring down the 1.
-4. -4. 16. -64. 0.
Okay, so then you
It's
can
gonna
just
be
attach,
x squared.
right? -4x plus 16. Now that we have that, what would we do?
You can do fill in the
Quadratic formula.
yeah.
Okay, to do the quadratic
A, B,
formula,
C.
you have to identify the A, B, and C. What's the A?
1, -4, 16.
Okay, so now you tell me what it will look like when...
Plus or minus.
Okay, but wait a minute.
Or,
The
no, it would be 4.
+4 because the B was already negative.
Plus or minus -4 squared.
Well, square root of -4 squared
Yeah.
minus...
4.
Alex, wake up.
This is 1/16.
All over 2, because 2 times A is 2 times 1, which is 2. What would you do next?
You would do the
Discriminant. Discriminant. Remember, determinant was when we were doing matrices. It's not the same thing. Okay, so do the discriminant and tell me what you get. Okay, what'd y'all get? Why are only a handful of people typing in the discriminant? Do you think they're going to do it for you tomorrow?
What?
-48. Okay, is that a perfect square? No. Okay, so what do we have to do when it's not a perfect square? Factor tree it. So what are the factors of 48? Okay, you could start there. 2's prime, so we got to break down 24. Okay, let's go with 4 and 6. Okay, the 2 keeps coming down because it's prime. That becomes a set of 2's. That 2 keeps coming down. This becomes a, right. So now, what all do we circle? So what's the only thing that stays in the house? The 3. Okay, before we continue, let's look up here. I can eliminate which ones? A and D can be eliminated. Now, I can also, without even finish, know what the answer is. Because look, B is -2 plus blah, blah, blah. C is +2 plus blah, blah, blah. If you have a 4 over 2, are you going to end up with a -2 or a +2? Positive, so it's C. Now, the way they got that rest is they kicked out this 2 and this 2 to make a 4. It was negative, so you put an I. So then it becomes 4 plus or minus 4I root 3. And remember, since we have a real part and a complex part, we put them both over 2. 4 over 2 is 2, plus or minus 4 over 2 is 2I root 3. They just chose in the answer to write it separately. They chose to write 2 plus 2I root 3 and 2 minus 2I root 3. Okay, I'm going to do number 20 real quick, and then we'll come back to number 19. All right, number 20, which solution set is correct for the system below? How would I do this? We would put them both in the calculator, okay? So y equals, tell me what the first equation is.
X squared plus 6 root 3
Okay, and then we type the second equation in, which is
X minus
we graph them, and what are we looking for?
let's see where they, like,
Where they intersect. So over here, where do those intersect? 2, 0, right? And then over here, -4, well, look at your answer choices and you'll know.
-4, -6.
Right. Okay, now let's look back to number 19. Okay, I'm going to give you like a 3-minute head start on this problem, and then I'm going over it. It's just like problem 18. Okay, so I'm going to give you about 3 minutes to see how far you can get, and then I'll go over it. Okay, the first thing that you need to do is graph it to find the one real solution. So tell me what it is. X cubed. Hold on 1 second. Let me clear out what's in there. X cubed minus what? Shh, Christian.
Sorry.
Okay, we graph it. Now, we know it's cubic, so we need 3 solutions, but we only see, well, it goes through it +3.
Yeah.
Okay, so that's the one real solution. Okay, now, so that
So you can
eliminates
mark
B
out D.
and D. Hold on, we'll talk about it later. Okay, that eliminates B and D, because we know there's one real solution at 3. The other 2 are imaginary, so we have to do what?
Do put it in the
Synthetic division, using the one real solution. So, looking up here, what numbers do I use?
22, -21.
Okay, then I'm going to go quickly. I bring down the 1, multiply by 3, that becomes -5, that becomes -15, that becomes 7, that becomes 21, remainder of 0. 1x squared minus 5x plus 7 can't be factored, so you must do the quadratic formula. So that will be +5 plus or minus the square root of -5 squared minus 4 times 1 times 7. Go ahead and be working on the discriminant for me. All over 2 times 1, which is 2. So I can kind of go ahead and look up here and see if anything is helpful. Look, without even worrying about the discriminant, 5 over 2. That says 5 over 4. This one says 5 over 2. So it's C. When you did the discriminant, you would have got a -3, and so the negative would have just come outside as an I.